Hey, everybody. Welcome to Adventures in Machine Learning. Today, I'm going to be your special host. I'm Gant Laborde, and with me today, I have wonderful panelists. I have Daniel. Daniel, say hi.
Hi.
And also Beryl.
Hi.
Awesome. So if you've listened to us before, you know these two wonderful people, but the person that you don't know who will be joining us today, and I promise you I will continually mess up his name, unless, of course, you're in the U.S., in which case you can't hear the difference between any accent. Alexey. Alexey, how you doing today?
I'm good. How are you? Hi.
Oh, fantastic.
Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course.
So, Alexey, this is our audience's first time hearing about you. And I think it would be great. Why don't you give us the short history of how you got into programming, how you got into data science. Spoiler alert, we're going to be talking a little bit about data science today, and how your career has brought you to this podcast.
Okay. So I think the first time I heard about programming was when I was like 9 or 10, and I found a book in the attic of my grandfather about programming. There's something about BASIC, and it had like all these blocks, like triangulars, rectangulars, like if conditions, like basically visual programming. And that was a lot of fun. So like doing programming without a computer. I didn't have a computer for quite a while till I was, 15 or something. So,
Wow.
So then I got a computer eventually, and then I had Delphi there, Borland Delphi. Maybe you heard about this. So this is like a thing where you can just drag and drop things and then like put all the logic, the entire logic in on click of a button, like, just code basically everything there, like what happens without following any programming, best practices. At least this is what I did for, 5 to 6 years while studying at university. And I studied databases and a bit of programming. Then I eventually graduated, started working as a Java developer. I am originally from Far East of Russia, and then after graduating, I moved to the central part of Russia. By central, I mean European part, like near Moscow. And then I worked there as a Java developer for a couple of years. Eventually, I ended up in Poland working in a Swiss bank as a Java developer. That was a lot of fun, but then I accidentally discovered the Coursera course about machine learning. That's like probably you hear this story like from everyone, like this is how people got into machine learning. And myself, I'm not an exception. So I saw this course and understood, okay, this is what I want to do. And then it all started from there. So basically, it was like 2012, I think, when I watched that video and that course. And I thought, okay, like I enjoy my work as a Java developer in a bank, but probably I will enjoy more having fun with, machine learning and all that. And so then I got a master's, and then I ended up in Berlin because I studied in Berlin. So I decided to stay to stay in Berlin after graduating. That's an amazing city. And I found my first job as a data scientist there. And since then, I've been working full time as a data scientist. I think it was 5 or 6 years ago. And now I'm a lead data scientist at a large online classifieds company. Probably if you're from the States, you don't know about this. It's OLX. People in Europe and India and South America know, because this is like one of the largest online classifieds websites there. But it's basically like Craigslist, but not in the States. Yeah. And this is where I work as a data scientist. And this is how I ended up here on this show. So I'm also writing a book, and this is a machine learning book camp. And so a few years ago, I think it was 1 year ago, I found out that I do like podcasts. like especially being a guest. And this is my real pleasure to be here, to talk to great people, to be able to answer all the questions, and then see other people enjoy this, and then reach out to me and saying, wow, like I can really relate to what you're saying. And this is like amazing. So thank you very much for giving me this opportunity. And yeah, thanks.
Absolutely. That was quite the story. I have to say, that's amazing. Starting off with, there's like tons of fun stories where a kid creeps into the attic and finds a book from the grandfather. Isn't that how like National Treasure starts? Like young Nicolas Cage finds his grandfather's book. And for you, instead of like launching this other, you started coding, and you said you started coding without a computer, which is amazing. Were you like opening a notebook and like writing down basic code? How's that adventure happen? Because that's a story very few people, I think, can really comprehend.
I'm not sure I remember. I think I was just reading it and trying to play it in my mind, like what's going on in this code. And, it didn't really have all these if statements that modern programming languages have. It had this go to, and then line 10, line 20, line 30, and then, go to something. Yeah, so that was like a puzzle that I had to solve to understand what's going on there. And it was fun.
So yeah, it's like a choose your adventure.
Yeah.
I had some other colleagues also living in Germany, but Russian. They were really very good developers. And do you think it's just a coincidence, or do you have a background of similarity, just became interested by yourself, you developed yourself with specific interest? Do you have something common in your background? Maybe, I don't know, you self-educate yourself better, maybe you find your own interests better. Do you think something common or just a coincidence?
Probably coincidence. I don't think it has to do with me being Russian or living in Germany. I think you can find people with similar history in pretty much every country. I imagine there were books in the States, in Sweden, or any other country where, like basically introduction to programming for kids. And actually, I know that Soviet Union, like people weren't big fans of programming of computers. Like it was more like, the ambition and the, the plans, like they didn't really invest into computers. So it was actually a good coincidence that my grandfather had this book. Because
nowadays there are some books like TensorFlow for babies,
Yes.
JavaScript for babies. Do you think those are interesting to have better developers in the future?
Yeah, let's see in 20 years.
Right. It's not even eager loaded TensorFlow. They're showing them TensorFlow 1. And it's just like your notebooks or coding without a computer. You have to wait till the well into the end to find out if you did everything right. That's awesome. So, okay, let's go through this again. Finding a book in the attic. You get into Java. I'm sorry. Just kidding. But actually Java, it's still pretty far away from a data science world as far as I know. Does everybody know is like data science and machine learning in the Java world? As far as I can tell, it's still just an object-oriented, large team kind of setup. Mm-hmm. So you kind of flip the switch over there, going from Java to machine learning. And then you said you did that through the Coursera course. And are you talking about the Andrew Ng? Yeah,
that one.
The Bible of,
exactly.
Machine learning. So yeah, and then you said in 2012, which I think it must have just came out or something like that.
Yeah, exactly. Yes. I think it was one of the first iterations, maybe second iteration.
That's pretty awesome. So I guess can you walk us through and we'll get into your book and we'll get a little bit more into data science and what you do now. But this evolution, you're a Java developer, you see this course. What about it kind of spoke to you? And I remember the course has a ridiculous amount of linear algebra. So if you say that that's the part that you liked, then we're going to hang up this episode, right? No, I'm just no, but quite seriously, I'm very interested. What was the part? Because it sounds like you were going a specific direction, Java with everything you're kind of doing here. And then this one course was a serious pivot. And inside there is something that like was a life-altering experience. What was it for you?
Yeah, so for me, it was First of all, like when I studied at university, I liked math. I liked things like we didn't have a class called machine learning, but we studied things that are somehow related, like time series analysis, statistics. Like I really liked that things and these things. But when I graduated and I was looking for a job, no job required that. So mostly it was like Java or C# or Python, just usual programming stuff. And so I didn't mind. So I really liked Java. So, well, actually, I didn't really know Java when I found a job, but like I thought, okay, this looks promising. So I think I can make a career in Java. And yeah, so it just, for me, it was like when I worked as a Java developer, I had some sort of maybe expectation versus reality mismatch. I thought, okay, job would be a lot more fun coming after university. Like when at university, I do a lot of different projects, like course projects, doing some research, all these things. And then I go to job and then I need to fix bugs. I need to, process tons of XML files and do that. It's fine. And sometimes it has its own challenges, like especially when I was working at a bank, like dealing with all the volume of data, it was challenging. But somehow I was missing that fun that I had at university, working on course projects and doing some research and that. And then when I saw the course, for me, it was that missing part that I didn't have at my job, like the part of having fun. Like, I mean, you know what I mean, right? So not that I really didn't like my job. I did like it, but like that part of having a bit of math or, trying to do something with data. And then I thought, okay, this is what I want to do. Like I want to play with data sets, play with machine learning models, and then to me also it has this like wow effect because you just, I don't know, like when it makes a prediction that, like it just looks at the data and says, okay, it's a cat, and then it's a cat, and then wow.
Yeah.
That's really nice. And, yeah, I think that was the main reason. And then going from Java to data science, it was like I need to study a lot of things, but at the end, I don't think all this theory was really necessary because at the end, most of the things I do as a data scientist now, they are mostly engineering things like connecting different things, like cleaning data, preprocessing data, deploying models. And then having this background as a developer, as a Java developer, really helped me. Even though now instead of using Java, I use Python, but some things are still the same, right? And while language changes, I think Java and Python are pretty different languages and use cases are different, but still like being a developer, like knowing all these engineering concepts, I think it really helped me. So I think it was a natural transition. Like it wasn't super difficult. So I think like now when I look back, I think software engineers make really good data scientists because they already know the engineering part of the job, right? They just need to brush up their math skills, which they probably like all the math they forgot from university. They just need to brush it up. But other than that, they have like 80% of the skills they need. And for me, it was the same case. So it wasn't that difficult.
That's awesome. So in a way, it was like you were looking for something and you finally got an ability to do it. And then it was kind of felt right to kind of like, oh, wow, I can do this all the time. I can play with data. I can see this happen and feel the crushing defeat when it says that cat is a piece of toast, but then also feel the elation when it says the cat is a cat. So works out well. Awesome. Yeah. That makes sense. Like, I could see how seeing what AI is able to do and then finally saying, okay, now I can come in here and finally touch that stuff. That's great. Now, I'll be honest with you, and I'm sure our other panelists have questions along the way. So I definitely want to get into the data science portion of like what it is that you do, what's in the meat of the book and things like that. So what I'll say here is, now that you're in this field, I'm sure Daniel's going to have like significant, awesome questions, but I would love to like ramp up into explain for our listeners, because we have listeners of all kinds of different levels. Some people might be having their aha moment like you did in 2012. What is the world of data science in Alexey's own way of describing it?
So, well, to me, data science is like, it's about extracting value from data and bringing this value to improve the business, improve the product, improve the process, whatever, like just using data to improve something. And in the industrial settings, it usually like when you work at a company, like especially if it's a product company, you want to improve, let's say, the user experience or make some things faster. So to me, data science is about using data for improving things. And then, of course, one big component of this is machine learning. So to me, machine learning is a tool of a data scientist. And data scientists use machine learning to improve these things, to bring business value, to optimize processes, to do all these things with data. So for me, data science is that. So using, like, it doesn't have to include machine learning, but it's one of the tools, the probably like most impactful ones. But even if it's, just simple queries and then calculating statistics, to me, it's also data science when you use data to bring value to your company.
Would you say like data engineering, in terms of like knowing Spark or Storm or Petabyte, would that be the component of a data scientist? Because when I started working as a data scientist, like initially they were very separate domains. Like people would hire for a data scientist and now for a data engineer. And now today it seems like when you're applying for a job, not only if as a data scientist, not only that, they want you to have like all the background for being a data engineer, like deploying models on Kubernetes and monitoring it. So do you think like data engineering also consists of that?
Well, I think also data engineering is an important component of a data science project. But then if you think about a data science project, there are many, many things. So first, like we need to identify a problem, right? So what we want to solve with data science, right? And then this is what product managers do. Then we need to analyze the existing data, come up with a certain goal to see like how, let's say we have a problem and we want to analyze how many users have this problem. This is data analytics, right? And then we have let's say we have all this data that our users generated, and then we need to put this data in a certain shape, in a certain form, so later we can use it in machine learning models. And this is what data engineers do. Right. And then once we have this data, we can use it to train a model. Like this is what data scientists do. And then, of course, we need to roll this out to production. This is what machine learning engineers do. But let's say you are a startup, right? So you are working at a startup and you want to just find one person, right, who will do something like who will use machine learning to bring value to your company. And then like you don't have money to hire all these 5-6 people to do that, right? You just need one person. And this is where it comes from, I guess. So like people just saw this, okay, machine learning, like data science, machine learning can do that. So let's hire a data scientist who will do all this magic for us. And I think for startups, it's the case. Many startups won't have. But let's say like larger companies, especially like tech giants, they already look for an entire team of different people with different profiles because they understand that a data scientist alone will not be able to do that. But to answer your original question, I think many data scientists, like it's very nice to have skill data engineering. So it's like an immediate big plus if somebody sees that this person can do data engineering. It means that this person can not only train a model, but can do all the other things to actually make this model useful. Right. Like that this person will not need to wait for a data engineer to actually prepare the data pipeline. They will not need to wait for an ML engineer to deploy a model. They can do it themselves. But then the question is like, how do you find these people who can do all these things? And this is like, not everyone can do this, right? So this is like very, like they're different skills, right? Training models, doing all this in production. Yeah. And so
maybe you can program a AI bot to figure out what person is more viable to do that with their skills on their resume.
There you go. A resume classifier.
There was actually a story when I was in between jobs. I was interviewing for a startup where they wanted to do resume parsing for companies. So the idea was that the company would, have an initial interview, which was actually talking with the chatbot. And the chatbot would parse your responses and see like if your skills, even if they were not like 100%, but if they were almost aligned, then the chatbot could make like a smart decision and say like, oh, this guy is, qualified enough for a second round interview.
Wow. Huh.
Wow.
Dangerous.
In Europe, we've got GDPR privacy rules. I don't know if you got something similar in the United States, but here you got restrictions about sharing data of companies. And let's say a company comes to you, they want a model, but they cannot share their data. What do you have such challenges?
Yeah,
And
of
how do
course.
you
Like
overcome them?
since OLX operates also in many European countries, so like Poland, Portugal, Romania, also Ukraine, but in Ukraine GDPR doesn't apply, and that's a challenge indeed. And we need to be very careful with personal data, which is phone number, email, many other things. And then in many cases, we simply cannot use this data, or we need to have a really good reason to use it. And the process usually is like we have a business case. Let's say we want to use emails, and then we go to our data protection officer, like a lawyer, and we need to convince this lawyer that we really need this data. And then this lawyer makes a decision if we are allowed to use this data or not. And of course, like we also need, in some cases, modify the privacy policy, like the user agreement, all that. And yeah, so basically we
Or
need
are
to
there
use.
some methods to encode the data just to make the
Yeah, of
data
course.
anonymous
Yes,
and then
yes,
the model like
yes.
so?
Of course, that as well. So, like, this would be the first question the lawyer will ask. Like, hey, can you just anonymize it? Like, why do you need the raw data? But sometimes you cannot anonymize it. Like, for example, for emails, sometimes, like in email, you can, like in Gmail, for example, when you use Gmail, you can just put dot everywhere and Gmail would get rid of this dot, just discard it. So you can, like, from your email, you can make many, many different email addresses just by putting dots everywhere in the name. Or you can have a plus something like your email, then plus something that at Gmail. And then after plus, you can put any arbitrary text, right? And then some people use that to create multiple accounts, but it's the same user. And we need to, let's say we want to find such cases. So we need to actually have the email that user entered. And then there is no, like if we hash it, like these two emails would be completely different, right? So somehow we need to get the original. And this is tricky. And then, of course, we need to involve lawyers. And yeah, so, but the bottom line is that like we need to be careful. And that's why this position, such as data protection officer, exists to make sure that we're not violating anything. So yeah, so we just need to be careful. Of course, we are ourselves trying our best, but then there is another person who makes sure that like who is doing some sort of audit to make sure that we're not accidentally
The
doing.
data scientist to make sure that the data is protected? Is it responsibility of you or somebody else in the company?
Well, everyone should at least know the, like, not maybe to the same level of details as lawyers do, but we as data scientists who process data, we should be aware and should take responsibility when dealing with the user data. We just need to realize that like it's possible to use data in a good way, but it's also possible to, in a way harm the user. And we need to be aware about this and use our judgment. And of course, if in any situation we're not sure, we need to talk to our legal department and clarify all the questions. So this is the responsibility of a data scientist, in my opinion. Like thinking about this, okay, like I'm not sure, I should probably talk to a lawyer. So this is the responsibility of data scientist, because a lawyer will not always come to you, hey, can I look at your code, right? They will not do this. Hey, can I look at your models? So this is,
You don't have lawyers asking to look at your code all the time?
I have not been asked yet. But
that's a significant. We always get into ethics with AI.
Mm-hmm.
I feel like this is just where we're at because we are seeing new things happen, and people are surprised constantly on what AI is doing. And whenever that happens, there's a brand new freedom that threatens a new security that constantly happens. The trade-off, and people are worried that we're going to trade wrong on the next move. Mm-hmm. And it's pretty interesting. In the States, we have professions that are held a little bit more accountable. For instance, like lawyers and doctors. It's a little bit more accountability for those particular things. Even enough, here's a fun story. We actually hold accountants personally liable. So if the CEO comes in and says, hey, cook these books, and then the accountant does that, that accountant can go to jail So what's funny is I think that what's interesting is we're finding out software for a long time has been put on the chopping block of possibly becoming a profession. And with data science and data engineering, I feel like we're getting these conversations over and over again. Are people personally liable for misuse or failure to clean and work with information like this? And that is specifically the job. It is personal and clear information. And we don't know yet what kind of things can be retroactively pulled out of a model that's been trained on a specific thing. We don't know what the effects of like maybe someone doing reversing of federated learning to try to get some kind of information. And also, as it is right now, I think like a lot of these things are very accessible. It's just a matter of us not understanding the science behind it. So it's a pretty strange area. Like, how do you hold everybody accountable all the time for something that might change next month?
Mm-hmm.
Leveling up is important. I spend at least an hour every day learning ways I can improve my business or take a break and listen to a good book. If you're looking to level up, I recommend you start out with the 12-week year as a system to plan out where you want to end up and how to get the results you want. You can get it free by going to audibletrial.com/code. That's audibletrial.com/code.
I hope it's not a question for me because I have no idea.
No, that you have to answer that for us. Also, we want to know where the global minimum is on a non-convex function. You need to tell us all these things. We want to know the answers. We thought you had them. No. That's just it. It's just sort of like coming back to the philosophy of these things, which is kind of nice. That's what podcasts are good at. And data science and kind of like our lines in that. But I think you drew a difference between the engineering and the science. And I have no idea where the legal would go with something like that. Those are really amazing questions. If anybody knows, I would love to know.
I mean, I think it's really, really tricky because a lot of data that is legal can give insights into people that sound almost borderline illegal, right? Like,
yeah.
For example, Facebook, if you open up their app, they'll automatically like have these products. Like if you just went shopping to the store, they'll have the product or what you had beforehand. And some people thought Facebook had actually been spying, and that wasn't the case. They just had access to like the clickstream data of like where they had been browsing before, what they purchased like in the stores. Because sometimes, the purchasing history, I don't know if that's legal or not, that's available, but they had all these clickstream data that they used. And technically that's legal, right? Because it doesn't seem like it gives much information. But with the right models, they get like all this information that seems to be very scarily accurate. So I think that's like an issue for AI ethics. Like what even legal data you have might be unethical to use in a way.
Yeah. This is gonna be an interesting road to watch as we go through this. And I think that as the information, people like Alexey, you're writing books sort of explaining what the process is. People need to know that just to even understand, because for a large portion of this, it's, sometimes it's magic. I've cleaned data sets before. I imagine you do something way better than what I do. You probably talk about that in your book, like, is there a preferred method? So let's get this back on data science. In your book, which is Machine Learning Book Camp, what are the topics that you cover in case we want to know any of those?
Yeah, so basically, like I told you about my background, so I was a Java developer and I decided to become a data scientist. And what worked for me best was a project-based learning. So like when I learned by doing something. And then I initially took, I think, a wrong path. I tried to study as much as possible, like to basically, read as much as possible, like learn all this theory. And when I tried to first compete on Kaggle, like after studying all this theory for 2 years, I couldn't. Like it all was useless. Like I felt like I don't know anything. I just needed to start from scratch. And this is when I really learned. This is when I really understood things. This is when I understood how to apply machine learning, how to use machine learning to solve real problems. Like all this theory, it wasn't useful. And so I realized that for me, the best way of learning things is by doing projects. Like, okay, I have a project and I do whatever it takes to do this project, but I focus on doing this. I don't try to cover everything in advance. I just focus on something. And this is the approach I'm trying to use in the book, to do a project-based learning. And in the book, there are now 7 chapters. And the first chapter is just a general outline, what like introduction, what machine learning is, like how to structure a machine learning project and things like this. But then the second chapter is already a real project, predicting the price of a car, starting from, okay, this is where you get the data from, and this is what you do, this is how you split the data set, this is how you evaluate your models, and this is how you train your model. And then the third chapter, is about predicting churn, and then about evaluating the model. So like there is a chapter about binary classification evaluation, and then I talk about deploying this, because I think many books cover deployment pretty late, if cover at all. And I think this is an important thing to close as much as possible, to have this loop, like, from the idea, from your initial idea to understanding the data, to building a model, and then to deploying it finally. And then you iterate on this loop. So I wanted to close this loop as soon as possible. So that's why, like in chapter 5, I have a chapter about deploying. And then I have another project, which is about risk scoring, predicting if a customer will be able to pay back the loan or not. And then another one, which I just finished, is about predicting. It's about training a neural network for image classification. So what the project I used there is predicting the type of clothes. So you basically take a picture of T-shirt, and then it says T-shirt. And then for me, it was the wow effect I had, like when I saw this machine learning course. And like, I think it looks like magic. Like you have a model that looks at a picture and then it says it's a T-shirt, and then it's a T-shirt. Wow.
Yeah.
So that's and now I just started writing a chapter about, so we have now this deep learning model, but what do we do next with this model? Like, how do we go about deploying this model? And
So,
then,
I want to stop you there and ask,
Yeah.
when you say deploying the model, I guess is copy the file over. Is that the entire chapter? No, let's go. Let's go into like what do you mean by deploying the model, and what does that process actually look like?
Yeah. So like, let's take a data scientist, right? So what data scientists usually do? They play with SQL, get some data, clean it, train a model. Of course, everything happens in Jupyter Notebook. So they have this XGBoost model that we save. And then what's next? Okay, so we have that, right? So we, as data scientists, we are really good at doing these things, like doing everything inside Jupyter. And then, but what is next? And this is what I call deploying. So taking this model that we produced and actually putting it somewhere so it is used, it makes impact on the user or whoever who uses this. So it just making this model available, and it can take any form. So it can be like putting the model in a web service. That's probably the simplest way. So then people can use this endpoint to basically send a request and get the predictions as a response. But then there are many other possible ways of doing this. Let's say you want to run your model only once per day, right? So you don't want to have a web service. Then you can put this model in Spark or somewhere else. And then there are multiple options, and it all depends on the use case you have. So this is what I mean deploying.
It's the practicality of it. That's
Yes.
absolutely necessary, I'm sure.
Yeah, exactly.
We were talking a bit ago of the engineering versus the science, and I think so this is getting into the engineering.
Yes, that's 100% engineering. So the science part is done, like it ends when you do model.save, and then the science part is over. Yeah. And then you need to actually do all this engineering work, like this 80% of effort, like to actually deploy it, make sure it's available. I mean, like, it's doesn't fail, like it's up and running all the time. Like there are metrics, the like auto scaling, and all these things.
There's this joke: this data engineer wakes up, sees the curtains are on fire, And then he looks at the curtains and sees the rate of spread and sees what's going on, goes over to the sink, fills a bucket with the exact amount of water, throws on the curtains, and then the curtains go out without spilling a drop. And then this data scientist wakes up and she sees the curtains are on fire. So she goes over to the sink, lights a match, puts it under there, and then proves that water will put out the fire. And that's it.
A good one.
I approve. But I think we're right. There's actually Daniel said it in a previous podcast. The requirements for people to get hired into these positions used to require PhDs, then they used to require masters, then they're requiring, and a little bit more. I could see that it's requiring an education combined with what you're saying, this other part, a significant pragmatic approach, a very like having the experience alongside of it as well. Is that kind of, Daniel? You said something similar to that, like over the past, I think it was you said every 5 years.
Yeah, I think because like to reiterate what I said again, I graduated with my master's in machine learning in 2012. But at that time, like any jobs that wanted to hire, they were only hiring PhDs because, machine learning, a large component of it is statistics. And I think traditionally in industry, when you were doing like research professions, they wanted a PhD because that showed your ability to do research. I have a story where when I used to work as a contractor at AT&T, I was working in a department that was like entirely PhDs. They hired me because like I was sort of going to be like an assistant researcher to the PhD. And I got along well with the department head. And he told me that he really disagreed with AT&T's policy because they wanted PhDs because that was like a sign, like a status that they could do all this research. But he said like PhDs, they do a specialization of a specialization. So if someone is like doing a PhD in math, they might be doing like n-dimensional algebraic topology and a specialization within that. And when they got aboard, then they were entirely ignorant about machine learning, so they had to learn from scratch. And he said it was more economical to hire like master's people who already knew the subject rather than having to like retrain PhD people. So I think, a lot of industries suffer from that bias because, sometimes people in industries who are not technical, they think PhDs sound like a good idea when in actuality, it might sometimes be self-destructive for them. But I think, the requirements got like much lowered because, as you said, Alexey, like a lot of startups are now using machine learning. And I think, and someone can disagree with me, is that with the availability of big data and data collection techniques, like if you want to make a startup, you just buy a subscription to like a data scraping, like Facebook ads or Google ads. You get like all the data yourself. You can rent out a couple of Spark clusters, and then you have your business going. So I think with the fact that with all this technology advanced in big data and the cloud in like the last 10 years, it made it very easily accessible for startups to do all the work. So then right now there's a lot more demand than there is actual supply of data scientists.
Yeah.
So like maybe about 60-70% of job boards I see these days are like for independent contractors or startups because like the technology is, so prevalent. And because you can like do heterogeneous mixing of the data, like you can have computer vision data along with NLP data. There's just infinite possibilities of coming up with something unique. I mean, now people can do, for example, like stock prediction techniques by using like stock data along with the news data, for example. So I think it's just a matter that the demand has outstripped supply.
That's really interesting. And I think that leans specifically into your teaching method, like give people projects, right? Alexey is like, that's such a cool thing. That's how I learned, by the way. We're similar in this aspect. You can tell me the philosophy and I love it. I mean, sure. I think, like Diffie-Hellman encryption, math can keep my attention you got me for 15 minutes. Let's do it. But it has to hit, it has to touch ground. That lightning has to touch. And if it doesn't, then, how are you going to go another 15 minutes, another hour, another year, another 4 years, So I think that's, the story of how you found a book in the attic and you were interested in a puzzle to you finally saw a course that unleashed that to the teaching method that you're doing in your book, those all align with a lot of us who are developers first, and I think that it's kind of nice to see that the market's willing to accept us.
And where do you think this data science is going? What do you think the future challenges and future focus?
Yeah, I don't know. Like when it comes to technology, I'm really excited with this no-code movement. Like being able to create Twitter by just clicking a mouse. Like you probably saw all these tools coming up in the recent year, and things that can automate, integrate with pretty much everything. And think soon enough we will have data science in these things. Like you can just take, if you need to, like let's say you have a website that you created in this node code tool, you have there a recommender system component. You just drag and drop, and here you go. You have a recommender system and things like that, or smart search. You just take this, put it there, and you have it. Or in that direction. So I think it becomes more and more commoditized. So previously, like 8 years ago, when there was a requirement to have a PhD, now very few jobs have this as a strict requirement. So usually it's nice to have, but not a must, right? But now companies, I think they are more focused on engineering skills. So they're not only interested in machine learning skills, but also want to make sure that the candidate is a good engineer.
Or courage also, I would say, because somebody with PhD is normally reluctant to dive into things because, let me check if it's in the literature, if other people did it, if it's the official way to do that. I have to be in the rules that I learned. Maybe learning so much is also limiting us, or how we define ourselves is so much limiting us. But if we say just, okay, I'm open to dive in.
Yeah, indeed. But what I wanted to say also, like that, of course, is important. But maybe this what you just mentioned is even more important than engineering skills. And a lot of people who have that, who want to move fast and want to experiment, they don't necessarily have these engineering skills. They don't always know how to use all these big data tools, all these AWS tools, like all these, I don't know, Kafka, like all these things. It's difficult, right? And I hope to see in the future that these requirements, like this engineering requirement, is like it becomes even easier for people to enter the field. So like what they need to have is like some sort of like understanding what machine learning can do, and that should be enough to get them going to start. Like with simple tools, with maybe drag and drops, and not being afraid to experiment and all that. I think this is important, and there are many people who are like that, who want to do these things. But now the learning curve is still steep, right? So you need to learn a lot of things to be able to do this. And I hope to see like that in 5 years, it will be a lot easier to do. Now we have all these tools like AutoML, where you can just, have a CSV file, put it there, and then go drink a cup of tea, come back and have a model. That's great, but still, you have to integrate this model, right? So the job doesn't stop there. But I think sooner it will be even easier to do other things and then concentrate really on how you can use that to bring value, to improve the life of your customers, to make your process faster or things like that, instead of spending a lot of time doing engineering things. So let's see, but I hope this is where it's going.
Awesome, everybody.
Hey, folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there, The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
We probably need to start wrapping up on time, so we will bring it to the final portion of the podcast where everybody gets to identify their picks. So if you're not familiar with this is the portion of the podcast where you get to choose something that you are interested in, and it could be machine learning related. It could have nothing to do with machine learning. It could be the most wild and interesting thing possible. So we'll start off. Daniel, do you have any picks for this week?
Yeah, I would say medium.com. It's basically now like, you know how everything's becoming standardized. So it's like the standardization for blogs and various independent articles. And I find it a really, really great source for learning new machine learning techniques and natural language processing techniques. I'm a big fan of actually two sites they have called NLP News, which is hosted by Dare.ai, and another one by Quantum Sync. So they have like really, really good news articles like summarizing NLP for the week, like advances they've done with transformers, new APIs that come out. And I think like 1 or 2 podcasts ago, someone recommended Towards Data Science, which is also a really, really good website, as they have like up-to-date articles on the newest techniques in ML and NLP. And I think it's, beforehand, people would have to like look through individual blogs, or start their own news feed in order to keep up to date with everything, which could be a little bit cumbersome. And I think the standardization is great because machine learning and AI, they are rapidly evolving fields. I mean, ML is like using the latest advances in neural networks, even in math, like the latest techniques in statistics or information theory. I mean, I think every other week, someone is finding a way of using like some subfield of math in order to improve machine learning. So I think that's a great way to like keep on top of all the latest trends that are going on.
Very nice, very nice. And listeners, definitely check out the links in this episode, and they'll have the links to those Medium publishers that Daniel was referring to. And I'll go next as a pick. And my pick is going to be, we had the guest Lawrence Moroney on this podcast, and he was awesome. That issue recently went out. It was one of my favorites for sure. But he also released a book, and when he was on the podcast, the book was not out. So I would like to say that I've purchased the book. It is out there, and it is available on Amazon. So it is AI and Machine Learning for Coders, which I think kind of aligns with everything that we've been talking about in this episode. So that works out quite well. And so definitely check the show notes. So his book is now available, and that is my pick for this particular episode. Beryl, do you have a pick?
Yes, I have a pick also. I will be a speaker at a European conference. It's Rise of AI. People can see it www.riseof.ai. And normally it's a physical conference in Berlin every year, where Alexey is located at the moment. However, this year it's going to be a virtual event due to pandemic. And it's an opportunity. Everybody can join for free to the conference. So you are very welcome from United States. And I will be talking about explainable AI, and hope to see you there.
Very cool. Yeah, I just pulled up the website on that. I'm very sad that you won't be on that stage. It's going to be virtual. This year of virtual.
Twice. It's extremely nice place where they organize, and top people of AI come there. They make demos. It's an excellent event. I hope you join once when it's really physical. This year, definitely join the virtual one. It's going to be amazing again.
Yeah, absolutely. I would love to. And actually, that would be a great place for all of us to kind of meet sometime once the world opens back up. I think that's it's been closed. Yeah. Okay. So when that opens back up, we'll see you all. And that sounds like a really cool one. So cool. Great pick. And then last, Alexey, what would you pick?
Yeah. So I recently founded a community of people who like data, like data analysts, data engineers, data scientists. It's called datatalks.club, and I would like to pick this. And I always was a fan of communities. Like this is how I got inspiration. Like when I just started my career, I would go frequently to a website called Java Talks and discuss different things, help other people. And when I started to do data science, I thought, okay, I should have something like this. And then I created Data Talks. And then forums weren't really popular. They stopped being popular that time. And I had 10 visitors per month. And then I gave up. But then recently, one of my readers reached out asking me, hey, is there a community where I can talk about your book? I thought, there is no. Maybe I should create it. And this is how Data Talks appeared. And then I really like this name because it goes back to when I started my career in Java Talks, being active in this community. And this is how I decided to come up with a name. So please check it out. So it's not about the book. There is one channel about the book, but my intention is not to keep it about the book, but rather to exchange experience, to help others, to if you have a problem, ask there and find projects together. Yeah, basically have a place to talk about data.
That is awesome. So it's data-talks.club, correct?
No, without dashes, just one word.
No dash.
Talks.
Just one word. Well, someone else is stealing your stuff.
Yeah, I think I'm stealing theirs because
Fair enough. That's okay. We'll push yours. Do not put dashes in there, everybody. We don't. That other place, they're stealing his stuff. Don't go to them unless they're a guest later on. In which case, we'll make friends. But if they're not a guest, they're our enemies. Complete hyperbole all the time. Sorry about that. That's a great ad. And I see you've got a place for joining with an email address. I will be joining very shortly. So that's awesome. Perfect. So I think that's everything else that we have here. I'm really, really happy with just getting the chance to meet you and hear this whole story. That's actually really inspiring. I'm going to add you on Twitter, of course. You have your Twitter URL. We'll add that to the show notes.
Mm-hmm.
And we'll keep up with all the stuff. And I'm looking forward to when all of us are sharing a drink at Rise of AI next year. So
hopefully, yes.
So that'll be fun. Thank you, everybody, for listening to this Adventures in Machine Learning podcast episode. We have fantastic guests this time and a lot of adventure. I think we did well. We didn't have Chuck this time. And, we didn't run around and set the house on fire. So I'm going to call this one a success. Till next time, everybody. Have a good one.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.